Kim Điệp Xú, hello, 大家好 and Sawadee So student who speak English, as well student who speak Thai. In this chapter, I cannot Google portfolio management in Thai language. So please all student, Khmer student, Thai student, as well student who speak English, all of you join together in this clip. This clip is very important that let you understand how to invest in portfolio. A bunch of investment, especially in security market. Okay, so before I start this topic, let's know my background. I was a PhD student in finance, of course for 2 years from Taiwan. Bachelor degree in finance banking from Thailand, master degree in business administration from Thailand. This is ID cards, my student ID card in Taiwan. My classmate, my advisor. This is the academic result, PhD coursework in finance, 4.33. Bachelor degree in finance banking, 2.76. Master degree in business administration, 3.53. Let's see the topic. Portfolio theory. I will conclude what portfolio means. A bunch of investment. You have a set of money, you have to allocate your capital by investing in risky asset and non-risky asset, because you don't want to take risk all of your money in one thing. If you lost your money, gone. If you invest in one thing, but if you allocate your money to invest in, for example, that you invest in buying stock, you might buy this company, you might buy that company. One company might be risky, one company might be low risk. That's called allocated capital or diversify your risk. This is a portfolio theory focus on. Now let's read the whole that build your understanding about the concept of portfolio theory. Risk versus return is the reason why investors invest in portfolio. It's clear in English meaning. The ideal goal in portfolio management is to create an optimal portfolio. Students remember about the optimal cost of capital. The same thing like optimal portfolio derived from the best risk return opportunity available given a particular set of risk constraints. Risk constraint, you are difficult to bear the risk. To be able to make decisions, it must be possible to quantify the degree of risk in a particular opportunity. The most common method is to use standard deviation of the expected return. Students have to memorize the word standard deviation. Variation, the distance between the mean and to that point. It's called the standard deviation of the expected return. What standard deviation tell you? Standard deviation is a risk. If the distance from the mean very far away from the mean, it means you have a lot of risk. But a small distance, a short distance from the mean to that point, it means you have low risk. What does risk very important to investor? Is it right or wrong? No. It depends on investor behavior. The theory of risk and return: high risk, high return; low risk, low return. What investor want? If investor want more return, they have daring to invest in a high risk asset. If investor is such kind like a chicken investor, it means investor are afraid of risk, so they must invest in a low risk asset or a low risk project. This is the whole yellow highlight want to tell you. Now let's go to another slide. This is an example. Circumstance or scenario. Scenario 1, 2, 3, 4. You get a return. Scenario 1, 10, 2, 3, 4. And probability. Future is uncertainty. So you cannot predict 100% rise of your investment. So that's why the word probability happen. Okay? So when you expect or average return, so memorize this word. Most of investment, they use the word expected. Okay? Expected is an average. Memorize this word. Okay? Don't translate directly from the word expect to your own language. Okay? Like in Cambodia, whole. Expect is a whole. You cannot translate in investment terminology. Okay? You cannot expect like that. Translate like that. In Thai language, the same. Okay, hope or ความหวังไม่ใช่นะครับอย่า translate แบบนั้นนะมันเป็นค่าเฉลี่ยนะครับ it is an average. Okay, so the word they write down like this. Okay, so take the return multiple by probability each scenario and you will get the expected return, and all four scenarios plus together. So all expected return of the four scenario, you have 13.5. Easy, okay? Move to another slide. Standard deviation. How to calculate standard deviation? So you have to learn statistics. I prepare the statistic for you, chapter by chapter 2. But now let's go with the theory first. And in the next clip, I will teach you the statistic related to the research. Not all of them, because we have fundamental of statistics. I hope that bachelor degree, master, or doctoral degree learn it in class. But statistics for research, I mean, I will focus on all tools that they take out from statistics to use in the research. Like that way, okay? I cannot teach you from statistic 1, statistic 2. It's you can Google and learn on your own. But I try to take all the methodology that most they use in research, as well bachelor degree, master degree, or doctoral degree. In the United States, some class they require students to complete research, or we can say a tiny thesis. Okay, back to our topic. So you got a total return just a moment ago. So if you want to calculate a standard deviation, this is a standard deviation of portfolio. So what is different between the standard deviation of portfolio and individual asset? If individual asset, they use S, standard deviation. If for a portfolio, they use sigma. A group, from the word portfolio, I already explained you a bunch of investment, a bunch of project, a bunch of asset investment, a bunch of stock you invest, a bunch of bond you invest. It means that you invest in different company in order to diversify your risk. That's why sigma mean the risk of portfolio. This is the way they calculate it. This is the probability here, okay, 1, 2, 3, 4, and x minus x bar. X bar is an expected or mean. You take x minus x bar, okay, and square, or summation probability multiplied by x minus x bar square and square root, and then you get a standard deviation, a portfolio standard deviation, a risk. Okay, so x minus x bar, which one is in x, which one is in x bar. So here they show you over here, okay, x minus x bar, okay, where is x bar? You have to calculate x bar first. Okay, the probability of x bar, how much is it? Okay, and see, you have to summation and divide by 4, and you will get x bar, right? Okay, so how is an x bar? The return over here, okay, x bar, you have 10 plus 12 plus 15 plus 19 and divide by 4, and take 10% divide that x bar, okay, 12% divide 10% minus x bar, 12% minus x bar from 4 of them, plus together divide by 4, okay, and then you got the result like this, okay, minus 3, minus 5, okay, so it means it must be x bar, it must be 13.5, okay, it must be 13.5, you take 10 minus 13.5, you got minus 3.5, like that, okay, and this one 12 minus 13.5, you will get minus 1.5, so on and so on, okay, and they do like this, x minus x bar square here, minus 3.5 square, you got 2.45, so on and so on, and multiple by, oh sorry, this is already, this is square, multiple by 0.2, you get 2.45, okay, so on and plus together variance and square root of variance, you got 2.66. It means the risk of this portfolio is 2.66%. I repeat again, risk just tell about the risk of that project, that investment, but it is not right or wrong with investor. It depends on investor character or investor behavior. Is an investor a chicken, or is an investor is like a bull investor, a bold investor, like that, okay? If they are chicken, they are not to invest in a high risk project, okay? Let's move on. Investment A, expected return 9% and the risk 2.5. Investment B, expected return 9% and the risk 4.0. They ask you between the two projects, A and B, which one is the best? So if we focus on the risk alone, for example, like 2.5, 4.0 in terms of risk, so the project will give the return the same return, but low risk. Which one do you want to choose? I choose the project A, investment A, because the same return and low risk. Why not? Okay, this is the way you choose, relying on expected return and risk. Okay, now let's move on. What about investment A 10%, investment B 20% with the risk 10%, and project A 10% with the risk 5%? Which one is the best? You cannot answer because different return, different risk. Now it depends on behavior of investor. If you dare taking risk to take risk, okay, risk 10% but you get high return. Low risk, low return. It depends on type, it depends on investor behavior. Okay, move on. Okay, and this case, return and risk, and take all that one return over here and the risk over here. Okay, high risk, high return. Okay, high risk, high return. For example, risk 25, you get return to 30. Just building a graph. Okay, you go to Excel. Okay, and put in the column Y as a return, column B as a X or risk. Okay, and then click on what you want align. You want a line like this, it will get like that. Okay, how to read that one? Bachelor degree student, you know how to read it, right? For example, like 25. Okay, 25 supposed to be here. Okay, here on X risk. Okay, risk here 25 over here. Okay, the point over here. Risk 25. It must be returned 230. Okay, here 230, right? Yes, how to build a graph. Go to Excel. Okay, go to Excel. Portfolio diversification. From the beginning, I did explain about the diversification. Okay, diverse the risk. You might invest in low risk project. Another capital, you might invest in a risk project or a risk company. For example, like you invest in security market, you might invest buying bond from the government 20 year or 30 year. This is a low risk. The government is low risk, and you might some of money you might invest in a private corporation. Okay, so that's such kind like taking risk. Okay, or private. What is the difference between private investment and public investment? Public investment means you buy bond from the government. You have the government guarantee your money paying back when it is mature. Okay, but for the corporation, the private corporation, by the law, if the corporation is closed or bankrupt, your money gone with the company by the law. That's why we say risky asset with the private corporation. Covariance and correlation, to study the relationship between two factors. Okay, so let's see. Covariance and correlation are considered. Covariance measure to what degree the return of two risky assets move in tandem. Does it move together? Does it move in the opposite way? Look at the sign, positive or negative. Okay. A positive covariance means that the return of the two assets move together. Okay. While a negative covariance means that they move inverse direction. Portfolio. You invest in a lot of projects. Okay. If the covariance has a positive sign, it means it moves in the same way, okay, that we say co-movement. Or if it has a negative sign, it means it moves inversely, in opposite way. So this is the formula how to calculate the covariance. Okay, y like this. Okay, summation probability multiplied by x minus x bar multiplied by y minus y bar. This is a research, not a statistic subject. Okay, a statistic subject. In a statistic subject, I have to show you example about this formula, okay? But in this research, how to use statistic way to analyze your research, okay? So I am guiding you to understand how to use covariance in a research, okay? The formula you see like this, student can Google and learn about the statistic of covariance on your own, okay? There are a lot of example, calculate, okay? Use Excel to calculate, okay? Very fast. Okay. Covariance is an absolute measure. Sometimes it become positive, sometimes become negative, okay? Okay, this is a formula of a correlation coefficient. Correlation coefficient, okay? Or you might say most of the time they use beta, okay? Beta. Correlation coefficient, beta. So when you see the equation, okay, and you will understand about the coefficient, I will tell you at that point. They replaced by R as a correlation, covariance. It relates to covariance, okay? We have to calculate covariance first and then take covariance divide by summation of X, summation of Y, okay? Two factors that you got a correlation. So the meaning of correlation, like the covariance, the same, because it used covariance as divided by summation of X and Y. It might be positive, it might be negative, okay? Here we go. You have to calculate covariance X, Y. This is a formula, okay? X and Y first, okay? Okay, so this we got X. This is a probability. Okay, assume that we have X minus X bar, Y minus Y bar like this, and calculate a correlation. Okay, so the correlation we got negative 0.481 or 48%, negative 48%. This is the opposite movement between X and Y. Okay, X increase, Y decrease, something like that. Okay. A large negative correlation confirms the strong tendency of the two investments to move inversely or in opposite way. Okay, if the correlation positive 1, okay, when the return from two securities move up and down together, co-movement in the same way. If negative, it means it move in inversely or in opposite way, okay? Uncorrelated, the coefficient equals 0. It means X and Y is not related each other. However, it's still better to be in this position than in a perfect positive correlation situation. Okay, so I mean they don't want to be 0, okay? At least it must be positive 1 or negative 1 from the coefficient. Unsystematic and systematic risk. Okay, systematic risk we cannot control, it is a market risk. Unsystematic risk we can control it by diversifying. A short explanation. Okay, here systematic risk is the risk that remain is called a market risk. We cannot control the market. The market might be flexible according to a lot of factors. Okay. For example, like the risk from the war from Ukraine, you see, all products, food product price goes up. Okay. The oil price goes up. Okay. A lot of factors that impacts on food price. Inflation from the oil price, the consequence of the COVID broke out and still remain until now. This is such kind all other factor in the market. We cannot control it. Okay. But for the unsystematic risk, we can control it by diversify just a moment ago. Okay. So this is a equation of total risk. Total risk, okay. Don't confuse with total risk, total risk, all risk. Okay. So this is a formula, okay. This is they explain you, okay. Sigma I, investment total risk, okay. Sigma S, investment systematic risk. Sigma U, investment unsystematic risk. Okay, so sigma I is total risk, S individual risk or systematic risk. Okay, so total risk equal systematic risk plus unsystematic risk. The student got the meaning of systematic risk and unsystematic risk just a moment ago. Okay, here we go. This is the correlation coefficient between two investment opportunity can be expressed like this, okay? The correlation between investment opportunity, okay? Just a formula, okay? Just a formula. So let's take a look at this one. The efficient frontier. The efficient frontiers mean the optimal investment. By looking at efficient frontier over here, okay, you have return at the left side, you have risk at the vertical line, okay, and then horizontal line, and you have return at the vertical lines, and the relationship between return and risk create the efficient frontier, which one is called efficient frontier, okay. So we can see if the return move up from 15%, okay, the risk goes up too. Okay, the risk go up too. Okay, and high return 25% with the risk about more than 50%. It's too much risk over here. Okay, okay, let's see what they explain you. Okay, the part of the curve between B and C, B and C. Okay, B and C over here, B and C, okay, represent the efficient frontier. Why? The efficient frontier because you got more return over here, but a lot of risk in the same time, okay? And the points of the curve between A and B over here, A and B, produce a lower return for high risk than point B, okay? Lower return that investor expect is to get more return, okay? Move on. Okay, now we're talking about expected return of portfolio, not individual, okay? Expected return of portfolio. The formula like this, okay? Risk-free rate. Most of the time, risk-free rate, if they don't tell us, we look at the treasury bill return. Most of the time, 2 to 2.5%, okay? Risk-free rate equal expected return of market risk, market rate, minus risk-free rate divided by, okay, standard deviation of the market multiplied by standard deviation of portfolio. This is how we calculate the expected return of portfolio, okay? Then the formula don't memorize it, okay? Just take a look at the Google. That's it. Don't memorize it. It is not a statistic, okay? If I teach, I don't let students memorize the formula. If I give the problem for them to solve, I give the formula. No need to memorize. A lot of formula. No need to memorize. I give the formula and then you just substitute the number. That's it. Now, talking about the capital asset pricing model. Who is the father of capital asset pricing model? Markowitz, okay, is the initiator After that, a lot of professors extend his theory, like a farmer friend, okay, Sharp, Lin, etc. Okay. So in asset pricing model, there are a lot of assumptions from Professor Markowitz. Number one, investors are risk averse and maximize expected utility. That means investor is a bold investor. They are taking risk. Okay. Number two, investors choose portfolio or investment on the basis of their expected mean and variance of return. Variance of return doesn't mean the risk of return. Okay. Most choose portfolio or investment on the basis of the expected mean and the variance of return. It depends on investor behavior. Are they a chicken or are they bold? Okay. Investors have a single period time horizon that is the same for all investors. He assumed that all investors expect single period time. Okay, I mean expect to get amount of money in the same time. Borrowing the lending at the risk-free rate are unrestricted. It means investor can borrow, can lend freely, but it is not actual in the way that the bank did. Okay. Investor expectation regarding the mean, variance, and covariance of asset return are homogeneous. It means all investors expect the same return. Homogeneous, the same return. There are no taxes and no transaction costs. In the real world now, it includes tax, it includes transaction costs, but in Markowitz, assume like that. Maybe in his period, I remember that his research was did around 1950, long time ago. So security market is different from now. Okay, it's different from that. That's why there are a lot of extensive theory from his research until now. This is what Markowitz expected. When he assumed like that, he created a model like this. This is called CAPM, Capital and Asset Pricing Model. The CAPM here, okay. So RP is a lot of authors, different authors, they might write down different letters as refer to each meaning, but as the common view, they are the same. So for this equation, RP refer to return of portfolio, not ICE. Okay? If they write down or ICE, it means one project or one company investment. If they wrote down RP, it means they allocate the money to invest in different company because the topic is portfolio management. A lot of investment in different project in different company. RP equal or F risk-free rate plus beta. Yes, beta is the coefficient just a moment ago, and that we know how to calculate the beta from that formula. Okay, RM market risk minus risk-free rate, like that. Okay, here we go. And this is the way we calculate beta. Okay, you see, covariance of return of portfolio, return of market return, divided by variance of market return. So there was a formula before. No need to memorize it. Okay. In the program, you just organize all the data in Excel column and click on covariance and click on beta, it calculates you automatically. But you have to know where is it from, because sometimes you just put in and the program calculate for you. You might not know about the source of the formula. That's why students have to learn statistics or research statistics. Okay, the formula beta greater than 1. What does it mean? Beta greater than 1, it means Morris. Okay, beta equal 1 should move in the same direction as the market return by the same amount. You see, they tell you, okay? Greater than 1, it means the investment will produce return in the same direction as the market, but to a larger extent. Beta equal 1, the same amount. Why they say the same amount? Because portfolio is a bunch of investment, right? Beta equals 0, investment return are not correlated, okay? A lot of projects are not correlated, okay, correlated. Here we go. This is an example, okay? Beta equals 0 over here, okay? I mean, this part is 0. So return of portfolio equal risk-free rate, okay? Beta equals 0.5, you get like this, okay? So the return of portfolio must be like this, okay? And so on and so on, okay? Here we go. Now, go to the case study. This is, I remember the two professors, okay? Eugene Farmer and Kenneth French. Both of them got a Nobel Prize in financial research. I remember one among them are Holland, okay, from Holland, okay. So we can see after Markowitz, there are a lot of authors extend his theory, like William Sharp, 1964. There is a Sharp formula, just a small formula, okay, but it help investor to make a decision in investment. If Sharp ratio is large, I mean, if you invest in that project, you will get more profit, more benefit by looking at Sharp formula, just a small formula. Okay, John Leader, 1965. Okay, extend Markowitz theory the same. Okay, both of them Nobel Prize. Okay, you see Nobel Prize Sharp in 1990. Why it take too long? Sharp 1964. In 1990, he got a Nobel Prize. Why? One create theory. We don't know it is real or not, but by using his formula from time to time in 1964 to 1989, something like that, before 1990, from 1964 to 1990, they apply his formula to invest in all assets. It showed that his formula, his Sharp ratio, realize it is real, that he said if Sharp ratio is a larger number, when you invest in that project, the project make you more profit. It realized it true from 1964 until now, until now, we can say until now. So how long does it take, you see? 36 years. And he got Nobel Prize. The theory first, and the experiment from 36 years, it proved that it is real. Okay, like what he created the formula. Okay, move on. talking about investment formula. This is efficient frontier, okay, CBTA, okay, and this is a line we call a cap M line, okay, or we say security market line, okay, risk free is stuff from risk free, okay, over here, okay. So the optimal, we went through the optimal point, right? The optimal point, it means high return, okay, so it between B and A, or the point between A, B and A, or consider as the best benefit for investor. Sigma R, the risk of the portfolio, okay? Expected return, this is expected mean return of portfolio. Okay. Over here, okay? Along the A, B, C are mean varying efficient because this portfolio also maximize expected return. This is what formula in Pharma Frank did, okay? RP is return of portfolio. We are studying portfolio management, a bunch of investment. So that's why it said return of portfolio. X and 1 minus X. It means you have a set of capital. You take one part of capital, invest in a risk-free rate, or risk-free rate. And the rest is 1 minus X, right? Because you have amount of money. You take one part, invest in risk-free rate, and another part invest in risk asset. Okay? It must be 1 minus 8. The rest, 1 minus 8. For example, like you have one capital, you take X out to invest in a risk-free rate, and the rest must be in a risky asset, the meaning of this equation. So if you convert to be mean return of portfolio, risk-free rate, you wrote down like this, the same, but the expected return of the risky asset over here. Okay, and at the end we got, okay, this is a minimum varying condition for M. Okay, M is a market risk. Okay, return in the market, expected return of the market. Okay, this is the expected return of all I's. All I mean individual or one asset equal expected return of Z, I mean zero risk in the market. Okay, plus expected return of market risk. Okay, market return. Okay, minus expected return of a market zero risk multiplied by beta IM, or coefficient between the return of individual asset plus a market return. Okay, the relation between individual asset and individual return and market return over here. Okay, this is the way they calculate the beta. The same formula before. Okay, covariance return of individual asset and return in the market divided by summation square or variance of the market. Okay, if we're talking about individual asset return and the market return, the beta must be like this. Okay. Okay. Sharp linear CAPM. Okay, both of them got Nobel Prize. Expected return of individual asset equal risk-free rate plus expected return of market minor risk-free rate multiplied by beta. Sharp linear capital asset pricing model. Here we go. The variance, the standard deviation, the summation square is the risk of the portfolio, but this one refers to the risk of, we say, a portfolio of market risk over here, and the formula like that, so no need to memorize about them. Okay, now we go to time series regression. Okay, time series regression time. Okay, we got a formula like this. Okay, yes, a moment from the beginning slide, you have or I is equal or F plus beta multiplied by or M minus or F plus error term. Okay, error term. I will explain you what is error term. Error term might be all factor that we do not include in our analysis. Okay, so what happened to the alpha? When you move RI to the left, you replace alpha over here because this is equation. Equation, for example, like you study from 9th grade, 11th or 12th grade high school, y equal a plus bx. This is a simple equation. A the same like alpha, A the same like RF. If they don't move RF here, but they move RF to the left side, they have to replace alpha in order to be in a right model, in a right equation. Like I gave you example like y equal a plus bx, like this. So just a moment I explain you about error term. Assume that all factor that affects the left side factor, but they do not include, for example, like factor that affect on GDP. A lot of factors that affect on GDP. Inflation, employment, okay, social unrest. For example, like we study only 3 factors effect on GDP, but other term it means a lot of factors beyond the 3 factors. It's still like a criminal, like import export, so on and so on, but we do not include. We took only 3 factors effect on the GDP, so the rest factor must be in here. This is the meaning how they use statistics in the research. Okay, alpha happened because of we move RI or F to the left side. We cannot leave it blank over here. If we leave it blank, it is not equation. Equation we have to have a constant over here. Before this we have RF as a constant. Like I told you, RF, if they don't tell you the percentage, you have to check with the treasury bill. Most of the time 2% or 2.5% or up to 3%. The number, it's called constant. But when you move it here, you have to replace the alpha. This is a number or constant. That's become a proper equation over here. And then the next, we will tell you about why we put alpha over here, because another professor extend the CAPM model to study about the alpha. And what is alpha called? Okay, alpha is called abnormal return. Because they argue with the CAPM model, this author argue with the CAPM model. He said CAPM model, if CAPM model it's really actual, a correct one, alpha must be 0. But when they replace all the number, click on the program, they still have constant number over here. It's not a 0. That's why alpha become abnormal return. beside expected return. This is the development of CAPM model by the next generation author or professor. And he also got a Nobel Prize too. Okay. So from that one, this is three-factor model. That alpha, there will be another case. I will give you another case talking about alpha, or it said abnormal return. So student in bachelor degree, master degree, and doctoral degree can learn together from previous one's clip now on. I combine together, okay? I explain you how to read the journal. After that, you practice on your own, okay? You can buy a research program, a starter, eView, SPSS on your own and install in your computer. Okay, now three-factor of Pharma Friend. This is an extension from the CAPM model. From just a moment, we move RF to the left, right? And this one, it is not a proper yet because we don't see a constant, okay? We have to have an alpha over here to become a proper equation. But pharma, just if you move RF to the right side, a part of here, it is original CAPM model. But pharma plus two-factor more SMB and SML, okay? And what is SMB? SMB is what they explain you over here, small minus big. And what is small? What is big? Small is the difference between the return on diversified portfolio of small and big stock. Talking about size, okay? And you wonder what is size? Capitalization. The size, I mean price of a share multiplied by outstanding share. That's become a size of a stock. And what about HML? High minus low. What is high? What is low? They define you clearly over here. Low book to market. Book value divided by market value. So you will question what is the book value? What is the market value? Book value is the initial offering price for the first time. When your company initial issue stock for the first time, it's called book value. And market price, after 1 year, 2 year, or 3 year, your share price go up or go down according to the market factor. Okay? This is called three-factor model of Pharma Friend. Here we go. In this case, it ended with the three-factor model. Okay, the three-factor model. And for the next clip, I will show you some theory and I will take the case three-factor, right? There are 4-factor, there are 5-factor, and 6-factor. So I will show you the case of three-factor first, and the 4-factor, and the 5-factor, and the 6-factor. Because a lot of also a professor extend the CAPM model. CAPM model, there is only one factor alone. One factor is the beta multiplied by RM minus RF. RM minus RF. Market risk minus risk-free rate is the one factor. Affect the return. That's it. That's called one factor. But pharma plus two factor more. Okay. SM small minus big SMB and HML highs minus low. But I already explained you what is the high book to market minus low book to market. Capitalization, okay, not just one, the whole, okay, the whole as the whole. And just a moment, I intro you about Jensen Alpha. What is it called? It is called abnormal return, abnormal performance. I will show you in the case, okay, and explain you thoroughly about that junction alpha. Now, the lesson go to the end. I hope bachelor student listen carefully and study harder than master and doctoral student because you just begin how to study master and doctoral way. Okay, so time is up. Okay, bye bye. จ่ายเจียนสวัสดีครับจุมเรียบเรีย